The next thing that we're going to look at is factoring, which is the opposite of multiplying polynomials. In this section, we're going to talk about factoring and the greatest common factor. This comes from section 6.1 of the textbook. So, in order to complete this section, please review the material for greatest common factor as it applies to numbers. Recall that the greatest common factor is what we used to divide or to simplify fractions. You want to be able to understand the distributive property, as we are going to be doing the opposite of it. You need to be able to apply rules of exponents, including the product rule and the quotient rule. And you need to know how to multiply and divide monomials. Greatest common factor was a topic that we looked at with fractions. Recall with fractions we use the GCF to simplify fractions by dividing it into the numerator and denominator. In this section we're going to see a second application of GCF with polynomials. We are also going to expand our definition of greatest common factor to include variables. Those variables can have exponents. So our definition that we're going to use, the greatest common factor as it applies to polynomials, this is an expression of highest degree that divides each term of a polynomial or list of expressions. When determining the GCF, look at the numbers and each variable separately. The greatest common factor for the numbers, again, we want to apply what we learned when we talked about fractions. And then for each variable, we will keep the smallest exponent. We take the smallest as that is the most that they all have in common. So let's look at some examples. Note here, all we are doing is finding the GCF. So if we look at example A, we have 6x cubed and 10x squared. So as I mentioned, the first thing we want to do is we want to take each number, or we want to look at the numbers and then look at each of the variables. So 6 and 10, we want to think of what is the largest number that divides into 6 and 10. They are both even, which means that they are both divisible by 2. And 2 is the largest number that goes into both. So now the x's. How many x's do they have in common? What is the most number of x's they have in common? Well, as I mentioned, we want to always go with the smaller exponent. Note that if we go with x cubed because we're thinking greatest, that would be wrong because x squared does not have 3 x's. So we always want to go with the smallest exponent. So in our GCF, we want x squared. If you have at least 3 x's, do you have at least 2? Yes. If you have 2 x's, do you have 2? Yes. And so this is our greatest common factor. All right, let's look at a little bit more challenging. Step it up just a little bit. Let's come over to example B. In example B, we have 3 terms. So we want to again start with our numbers. What is the largest number that goes into 15, -9, and 27? Well, all of these are divisible by 3, and that is the largest number that goes into both, or in all of them. So we have 3. What is the most number of y's that they have in common? That is also going to be 3 y's. If you have 5 y's, you have at least 3. If you have 4 y's, you have at least 3. And if you have 3 y's, well, you have 3 y's. And so we have y cubed. So our GCF is 3y cubed. And finally, our last example, we have x to the 5th y cubed, x to the 4th y to the 4th, and x to the 6th y squared. So starting with the x's, remember we want to take each variable individually. So starting with our x's, we have 5, 4, and 6. What is the most that they have in common? Well, if they all have 4, or 4 is our smallest exponent, they all have at least 4 x's. So that is going to be in our GCF. If we look at the y's we have 3, 4, and 2. 2 is the smallest exponent. Therefore, they all have at least 2 y's. And so this is our GCF for these 3 terms. So now let's apply what we just talked about to factoring. The first step when factoring anything is to factor out a GCF if possible. So in order to do this, we want to determine the GCF for all terms in the polynomial. Write the GCF to the left or outside a set of parentheses. Divide each term by the monomial and write the result inside the parentheses. Check that there are no other common factors that can be factored out, and then check your answer using distribution. A couple things to note when you do this. Factoring out a GCF is the exact opposite of distribution, so keep that in mind. When factoring out a GCF, you should have the same number of terms inside the parentheses as you do in the original problem. Basically saying that if you cannot combine terms in the original problem, you should not be able to combine terms when you factor out your GCF. Since we are dividing, if everything in a term cancels out, you are left with a 1. Also note, if the leading term is negative, you can factor the negative out with the GCF. We'll explain this in a little bit. So now let's go ahead and apply this to some examples. So if we look at example A, we have 5x squared plus 30. And so let's start with the numbers. What is the largest number that goes into 5 and 30? It is 5. Note that there are no variables in our greatest common factor. We have one term that has 2, we have another one that has no x's. So there are no x's in common in terms of our 2 terms. So our greatest common factor is just 5. So I'm going to write it to the left of a set of parentheses. And then now inside the parentheses, I want to divide each term by 5. So 5x squared, if I divide by 5, the 5's cancel, leaving me with just x squared. And my second term, if I divide 30 by 5, I get 6. So we have 5 times x squared plus 6. And we're done. Let's look at example B. Example B, we have 18x cubed, 27x squared. So let's start with the numbers. What is the largest number that goes into 18 and 27? Many of you may say 3, but keep in mind we want the largest number. And the largest number that goes into both is 9. So 3 is a common factor, but it is not the greatest. And since we do want greatest, we're going to go with 9. So now what is the most number of x's that they have in common? Well, our smaller exponent, remember we go with the smaller exponent, is 2. So our greatest common factor is 9x squared. I'm going to write that to the left of a set of parentheses. And then now I want to divide each term by 9x squared. So 18 divided by 9 is 2. X cubed, if I take away x squared from that, I am left with x. And then my last term, my second term, if we divide by 9x squared, we get 27 divided by 9 is 3. And my x squareds cancel, meaning that I have no more inside my parentheses in that term. And so we are done. All right, let's look at example C. Example C, we have 3 terms now. So let's start with our numbers, 16, 12, and 4. The largest thing that goes into all of those is 4. So we get 4. What's the most number of x's that they have in common? Well, they should all have at least 3, so I'm going to go with x cubed. And then now if I divide each term by 4x cubed, 16 divided by 4 is 4. X to the 5th, if we take away 3 x's, I'm left with 2. So 4x squared. My second term, if we divide by 4x cubed, 12 divided by 4 is minus 3. X to the 4th, if I take away 3 of them, I'm left with just x. Then for my last term, 4x cubed divided by 4x cubed, everything cancels, and so this is an example where remember that we are dividing. Anything divided by itself is 1. All right, let's go over to example D. This one's a little bit more complicated because we got several variables running around. But same idea, we're just going to take it step by step. So to start off with, 27, -9, and 81 are all divisible by 9. X's, what's the most number of x's they have in common? Well, we have 2, 1, and 1. They all have at least 1 x. And my y's, we have 3, 2, and 1. They all have at least 1. So our greatest common factor is 9xy. Okay, so now let's go ahead and divide each term by our greatest common factor. So if we divide each term by the greatest common factor, the first one, we get 27 divided by 9 is 3. If I have 2 x's and I take 1 away, I'm left with 1. If I have 3 y's and I take 1 away, I'm left with y squared. My second term, my 9's cancel, my x's cancel, my y's, I am left with 1y. If we have 2, take away 1, we're left with 1. And finally, my last term, 81 divided by 9 is 9. My x's cancel, my y's cancel, and I'm done. All right, example E. This is one where we're going to start talking about factoring out a negative. And for now, ultimately it doesn't matter on this problem, but let's just practice factoring out a negative because this is something we will need later on. So, as I said, let's go ahead and start with our numbers. The largest number that goes into 12 and 18 is 6. But I'm going to factor out instead of just a 6, I'm going to factor out a -6. So now we want to divide and note that there are no x's in the greatest common factor as the second term has no x's. So now if we divide each term by -6, -12 divided by 6 is 2. Since we didn't take out any x's, we'll leave them there, so we have 2x squared. And then now we do need to be careful on the rest of these because we do want to remember we're dividing by a -6. So positive 18 divided by -6 is -3. And you're done. All right, let's come over to example F, our last example. Again, I want to factor out a negative. We're going to also factor out the largest negative that goes into every single one of these terms, which looks like it is 6. So factor out a -6. How many x's do we need? Well, the smallest exponent is a 2, and so I'm going to factor out an x squared. How many y's can we factor out? Well, the smallest one is 1, and so we're going to factor out 1y. Now let's go ahead and divide each term by negative 6 x squared y. So the first term, negative 12 divided by negative 6 is positive 2. X cubed, if we have 3 x's and we take 2 away, we're left with 1. If we have 2 y's and take 1 away, we're left with 1. So our first term is 2xy. For our second term, negative 18 divided by negative 6 is plus 3. X cubed, if we have 3, take 2 away, we're left with 1x. And for the y's, we already factored out the 1y, and so we're done with this term. Our last term, we have 24 divided by negative 6 is negative 4. We've already factored out both of the x's. We factored out the y, and so we are done. All right, that takes care of factoring out the greatest common factor. Let's look at one of these just to show how are we going to check them, because that is something I recommend in this section. You should always check your solution, not with the computer, not with your friends, not with your instructor, not with a tutor. You can do this all by yourself. So let's look at example C again and talk about how do we check this. So in order to check this, what we're going to do is multiply back through. This is going to be distributing. So we're going to go ahead and multiply 4x cubed times 4x squared. We get 4 times 4 is 16. Add our exponents, we get x to the 5th. We have 4x cubed minus 3 times negative 3x gives us minus 4 times 3 is 12. X cubed times x, we add our exponents, we get x to the 4th. And then 4x cubed times 1 is plus 4x cubed. Is this the original problem? Yes, it is, which means that my original factoring is correct. The only thing that you might get stuck on with this is, did you factor out the greatest common factor as opposed to just a common factor? When will we see this again? Factoring out the GCF is always the first step when factoring any polynomial. We will expand on the concept when we discuss factor by grouping in the next section. We will expand on this concept when discussing simplifying and performing operations with rational expressions and radical expressions. Go ahead and try the following problems on your own. If you have any questions, please bring your answers as well as any questions that you have to class.